Tic-Tac-Toe game is one of the first games that I created. But when I was creating it, I didn't use Unity, I was learning C language. It was a while back, and I think it's a good project that you can start with to learn programming or visual scripting. And in this video, that is exactly what I'm trying to do, is show you how to create this Tic-Tac-Toe game, with hopes that you can learn a lot from this video. If you're looking for some other tutorials on Unity, check out my channel. I have lots of tutorials that I've been making, and with that, enjoy the video. I have already installed Bolt. If you need more instructions how to install Bolt, I'll leave a link in the description where I go through the process of installing Bolt, but let's get started. So for art, the only thing that I'm gonna use is a white pixel. I'll create the game using UI. Let's go and create a new image. Now we have an image game object. I can select canvas, click F, and that's gonna focus the whole canvas. The image currently has no source, so I'm gonna use that white pixel for the source. Now, a Tic-Tac-Toe game is a 3x3 grid, so I'll actually create a grid, create a new object. I'll name it grid, and for this grid object, I'm gonna add a component, grid layout group. I can add that image inside here. I'll rename the image from image to box, because that's gonna be a box inside the grid. And let me actually create a prefab out of it, okay? Select grid, go to rectangle transform, and holding Alt down, I'll stretch the game object to fill the whole canvas. Now, how the grid works is if I have multiple boxes in here, so I'll select a box and duplicate it, you can see that it's just adding those boxes. So I'll need 9 boxes. That's 9 boxes right there. And currently the grid is trying to fill in as much as it can. So what I want to do is actually create a constraint. So I can either use fixed column count or fixed row, it doesn't really matter. All I need to do is set the value to 3. To center the grid in the middle, I can go under child alignment, and instead of upper left, select middle center. That centers it. And to create that tic-tac-toe grid, I can space those squares. So let's do 10, 10, something like that. And now we have a tic-tac-toe grid. Now I want to modify the box prefab to add text inside there displaying X or O. Now one way you can add the prefab is by double clicking on the prefab, and that goes into the prefab edit mode. But for UI elements, you can't really see anything in the scene. You can go to game view and try to make something using that. But the other way of doing it is actually going into your scene view and just modify one of them here. So after you modify, you can save those settings. I want to add a text field, so let's add a text. Again, go to rectangular transform and we'll stretch it in horizontal and vertical. Center the text in the middle. Let's use a X for testing. And I think font size 90 is going to work for me. Let's try for O, make sure that looks good. That works perfect. Now to save this change to all of the other prefabs, you can select the prefab that we just modified, and right here, go and overwrite and apply to all. And you can see that change that we did to that one box was saved to the prefab, and all of the other boxes got reset. But I actually want to remove the text from here, so overwrite it again, and that removes the text. Now with the logic, what I want to do is on click to actually set the X or O on that box. So for that, we'll add a flow machine, which is a Bolt component, and that's where we're going to add the logic. For the flow machine, you have two options, embedded and macro. And if you're working with a prefab, you should always go with the macro. Otherwise, you're going to have some problems. Let's create new, and I'll just call it box logic. Save. That creates a file right here, box logic. One thing that I'll need in my flow graph is the connection to the text. So the way I'm going to do it is actually create a variable, call it text, and the variable, it's going to be a game object, and I can drag and pass in the text here. Before I go edit the graph, let's overwrite the prefab, apply to all, and let's go edit the graph. So I don't need that, I can remove it. I have the text variable right here, and the event that I want to listen for is on pointer click. So add that event. So whenever the pointer is clicked on this box, what I want to do is, for now, let's set text of the text field, and I can use the text object that we have here to modify that text object. And for now, I'll just set it to X. So let's go and test it out. Click play. If I click on any of these boxes, they should get an X. And there you go. We got that working. Now in Tic-Tac-Toe, you alternate between X and O, and you can play player versus player or player versus computer. But right now I'm just going to do player versus player. To switch between the players, we need a place to keep track of whose turn it is. And I'll add another logic on the grid. It's also going to be a flow machine. And since this one is not a prefab, I'm going to use an embedded source. Now I want to create a variable that I'll be using for keeping track of whose turn it is. And I want to create a scene variable. So let's go to added graph, and right here in variables under scenes, I can create a variable. So I'll just call it xTurn. Click add variable, and this one is going to be Boolean. So either true or false. Now, if you want to randomize who starts first, we can do that on start. So I want to change the xTurn variable on start, and you can add the variable by dragging inside the graph, but that's going to give you a get variable unit. If you want the set variable unit, you can hold Alt down, and that's going to switch it to set, let it go, and now we have this set variable. So we'll set it on start, and the value that we'll pass in here will be random. So for that, look for random range and use the integer output option. The values that I want to get from random range is 0 or 1, and to get that range, I need to set max to 2, because for the integer version of it, the max value is exclusive. That means that the 2 is never going to be actually sent out. And after I get that random number, I want to check if it equals to 0. If it equals to 0, that means it's going to be true. That's just a random Boolean value that we're going to get from this. So now that we have a variable and we randomly select who starts first, we can go back to our box and into our flow graph. And in here, if we select scene, we can see that variable. So this variable returns true and false, and we can switch which value we pass in inside here. The way you can do that is by using one of the controllers, and it's the select option. I can pass in a Boolean value inside here. So if it is true, then we can pass one string, and I'll say X. And if it's false, I'll pass another string, which is going to be O. So this logic right here is going to check based on whose turn it is and pass the appropriate string value for our text. Now, after this player takes a turn, that means that it's the other person's turn, and we need to modify the xTurn variable. So let's again drag the variable in, hold Alt down to switch it to set. So after we set the text, we want to change whose turn it is. We'll add another get unit for our variable. And if you want to change the Boolean from true to false or false to true, you can go and use one of the logics, and it's the negate. So this one is going to take the opposite. We can pass that value to set to a variable, and that logic should be done. So let's close that, click play. I have no idea whose turn it is first. Looks like it started with X. Next one is O, X, O. So our logic works great. Now we still have some issues. For instance, if I click on this box, there's nothing stopping me from clicking it again. So I can toggle the values of it, which is not what we're looking for. So let's go ahead and fix that. So let's go to added graph. To fix that, there's a pretty simple solution that Bolt has, and it is using once unit. So this unit right here, and we can connect it right here. This will make sure that the logic of clicking on this box will only happen once. Let's go click play and make sure that it fixed it. So if I click on here, you can see that I no longer can click on the same box. That's good. Now, before I start checking if anyone won, let's add a text at the bottom saying whose turn it is, and also add a restart button. One other quick thing that I'm going to do is for our cell size, I'm going to make it a little bit bigger because I think we have enough room to make it bigger. And now let's add another text UI, stretch it in horizontal, and we'll move it here. The height of it, let's set it to 50. And for text, center it. Text color, I'll choose white. And font size, I'll make it 40. Now in here, we can say xTurn, but we'll need to change based on whose turn it is. I'll add a variable to my grid so I can connect turn text there. Click add, game object, and let's drag and connect it here. Okay, so we have the turn text connected and ready for our logic to switch it. And the other thing that I want to add is a text button to restart the game. So I'll position it in the corner, make the height 50. I guess I have to reposition it again. Font size 40, and it's gonna be restart. I'll set the color to white. And for restart, we need to add another component with the logic for restarting. So let's add a flow machine. I'll use an embedded, added graph. And I'm also going to listen to the event on pointer click. If the player clicks on restart, the way that I'm going to restart the game is by reloading the scene. So I'll access the scene manager and use the load scene by scene name. The name of my scene is game, so I'll pass that in. And now I can close it. You can see the name of your scene right here in the hierarchy. One way you can change the scene name is by going and saving as, and that gives you an option of naming your scene. So I can quickly check, make sure that the restart button is working. So if I click restart, you can see that the scene gets restarted. So the next step is to change the text right here based on whose turn it is. And to do that, I'll have to do some changes. So let's go to the box logic graph. I just noticed that my scene variables is not actually saying X turn. So let's fix that turn, and then you have to manually switch it everywhere. So let's select that, Control X to cut that out. And instead, what I'm gonna do is trigger a custom event on the parent game object, which is the grid. I'll name the event move, and for the object, I'll pass in get parent. This will trigger a custom event on the grid, which is the parent of our boxes. So now we can go in the grid, edit graph, and in here, we can add a custom event, and the custom event name is move. The first thing that we'll want to do is flip the turn. So Control V to paste those units in. And let's switch also here to use X turn. Now I have the object turn text right here, and I want to change the text of this text object. So let's set text. So the first time I want to change it is on start. We'll need to get the variable X turn. And based on that, we will use the select again. So pass in the selected value. I have to reconnect that. For true, that means it's going to be X turns. So we'll say X turn. And for the other one, we're going to say it's O turn. So that's the logic of displaying whose turn it is. And also I want to set the text after I swapped whose turn it is. Let's go test it out. Click play. So it says it's O turn. And there we go. We click and it's actually O's turn. X, O. So that is working. And now let's create the logic for checking who wins. There's total 8 ways you can win the game. And there is different approaches that you can take to check if you won the game. I tried to use the simplest one, so it'd be easier to understand. And the test for the win, I'm gonna do inside of the grid graph. I'll need another variable and I'll use a scene variable. And this one's gonna store the state if we won or not. So I'll just call it won. It's gonna be Boolean, and by default, it's gonna be false. Now the place where I want to actually add the check is right here when we run the custom event. And I actually want to do it before I change the player. So let's disconnect here. And since the logic for checking if someone won is kind of bulky, I'm going to actually use a super unit. A super unit is just another graph. It helps a lot to organize the graphs. You can go inside the super unit by double clicking on that super unit. And in here, we start with an input and an output. We can have control inputs, control outputs, and those are the green arrows, flows, and also value inputs and value outputs. I'm looking for just one control input, and it's gonna be in, and I'll have 2 control outputs. It's gonna be true and false. So 1 input and 2 output flows. I can create a title for this super unit. So I'll call it 1. And if we go back, now we can see those connections here. And the way I'm gonna connect them is when we trigger custom event, it's gonna trigger the 1 logic. And if we get a false, then we just want to continue on with our previous logic. So let's go back inside here, and inside here, we need to check for those wins. Like I mentioned already, there's 8 ways you can win. So the approach that I'm gonna take to check for those wins is to create another super unit. So we can go inside here. I'll name it win test. I'll have a control input, and it's gonna be in, can hide the label, and I'll have a control output, and just be out. Hide the label as well, but also I want to have value inputs. I'll have 3 value inputs, and you'll see in a little bit why I have 3 input values. So how I'm gonna set it up is hide the label, it's gonna integer, and also enable has default value. That will allow us to pass in an input. So do the same thing for 2 more inputs. So there we go, we have 3 inputs now, and these inputs are integers. So let me go back here, and this is how the unit looks now. Now, those inputs are going to be the places where we're going to check in the grid for the values to be the same. So for instance, if we're looking for a win that is on these 3 boxes, the values that I want to pass is 0, 1, and 2. Same thing here. If I want to check these boxes, it's going to be 3, 4, 5, and so on. So the first check is going to be 0, 1, 2. I'll connect it in here. For a start, I'm just going to be checking for 1 possible win. And after we do the win test, what I want to do is check if the 1 variable is set to true. So I'll use a branch, connect it here. And if it's true, I'll pass it out true. If it's false, I'll pass out false. So that's the end logic of it. And a little bit later, we'll add all the other 7 variations of the wins. So let's go inside here and finish the setup for this unit. The values that we get here, 0, 1, and 2, are the child position of our boxes inside the grid. So that is what I'm going to be using it for. So use get child, and I can pass in the index, and I can do the same for the other 2. Okay. Now this child, which is the box game object, has a object variable text that we use to get access to the text, and we'll actually use that variable in this case as well. So let's add a unit, get object variable. We can connect the transform, and the variable name is text. So do the same thing for the other 2, connect them like that. And now we can check if the text actually is matching. To get the text, we can use get text from the text element, and that will get us the text. We can search for string equals value, and we can leave it empty, and this will return true if it's empty, but I want the opposite of that, and for that I can use the negate. Let me move the output. Now what I want to do next is, if this is true, which means that this first child that we're looking for is not empty, I want to compare the next 2 and check if they're equal to each other. So the way that you can do that is by connecting to an AND. How this unit is going to work, when we get a true value coming from this negate, it will check and make sure that B is true as well. If the negate is false, then it just returns false, because if one of those is actually false, it's just false. Both of them needs to be true for the true output to happen. So now we can compare these 2 texts together, pass in the value of the get text, and pass in the value of the second get text. We can connect this value now to this AND, but we still need to check and make sure that the third one is also the same as the other 2. And to do that, we can add another AND and make another check here. So exactly the same. It doesn't matter which one we use, the first one or the second one, the result is going to be the same. So let me try to summarize this logic here. So first, I check, make sure that first text that we're checking is not empty. If it is empty, that means there's no win, so I just want to get out right away. If it's not empty, then I go ahead and compare the next 2 values. If those values are the same, then I compare the last value with one of those values. And the final result, if we get a true, that means there is a win. If we get a false, that means there's no win. So now that I know the logic, what I want to do is connect it to a branch. Our branch is going to be connected to the input. If we get a false, we'll just continue on. But if we get a true, that means we got a win. What I want to do first, set the scene variable 1 to true. So let's get that in, set, connected here. And the value we want to pass in is Boolean literal, and we want to set it to true. The second thing that I want to do is change the color of those boxes. So this is going to be a little bit messy in how I'm going to connect this, but I don't see a cleaner way to do it. So each box has an image, and I want to change the color. So set color, I have 3 images, connect the other 2 as well. It's a little bit messy, but I hope you guys can follow this logic here. And then I can connect it to a flow. So after I set the first one, set the second one, set the third one, and after that one, we can connect to the out. That means we're done with the logic. Now I'll connect a color literal so that I can pass in the same color for all 3 of them. Let's choose an orange color, something like that. So there was a lot of logic here, and I hope I gave enough information about what I was doing here and you can understand that. Let's go back here, make sure that everything is good here. So I think we're ready to test it out. But like I said, the only win that I'm checking is for the horizontal. So let's see if we can get that win. And there we go. We got that win. It marks them orange, so that's great. The logic is working like we expected. So now I can go back here and add all the rest of the checks. So there is total 8, link them all together. And after the final one, I'm connecting to the branch. So the horizontal ones are gonna go 3, 4, 5, 6, 7, 8. So I think that's all of the wins. Hopefully I didn't make any mistakes. Let's go inside here and we can test out some other combinations. So that one is still working. And we still have one problem, is that after someone wins, we allow them to continue playing. So let's go and fix that. We'll go into the box logic, edit graph. And inside here, right before the once, I want to add a branch. And what I'm checking for if we won. If it's false, if we haven't won yet, we allow the logic to continue. Otherwise, we block them from making a move. Let's test it out one more time. There we go. And we can place any more afterwards. We start, so no win there. And there you go. I walked you through how to create a tic-tac-toe game in Unity using visual scripting. I hope you guys found it very useful and I gave enough information for you guys to follow along and to learn something. If you want to see more tutorials on Unity, check out my channel. I have lots more videos that I made and I'm planning to make lots more. So if you like my content, click on the like button, subscribe to my channel, and I'll see you in the next one.